Hi. Welcome to my seminar. My name is Remus Pereni. I'm a software architect and CTO of Yonder, and I'm delighted to have you as my host, my guest, actually, sorry. I've been working on technical tracks since 1998 with Yonder. This is where I get my batteries recharged. And I've spent my past years doing architecture reviews and also helping the M&A teams with the technology due diligence process. And during these moments, I got some insights by doing X-rays or CT scans over hundreds of software products that hopefully will help you as well deal with your legacy product. By the way, we are recording this, so if you don't like to see your name, or if you would like to watch this later, be aware of this. We are running a small pool, so please be so kind and answer the two questions. And let's move on. So based on this experience, I will try to discuss about whether you must spend effort on innovation. My initial wording was should, but of course, if I ask, should I spend effort on innovation, the answer is always yes. But the question, do I must do it? It's a little bit of a different question. So we'll discuss about this a little bit at the beginning. I'm going to discuss about competition battlegrounds, because competition, you will see, it's quite important in answering this question. And also I will discuss about options to move to the cloud and choosing the optimal SaaS maturity level, because not all levels are equal in terms of opportunities, but also in terms of costs. So understanding what could be your optimal level is fairly important. Speaking of modernization, APIs are usually a good way to do it. So we'll discuss a little bit about APIs and also about AI, ML, and what are kind of the prerequisites in doing AI and ML. And I see basically that the major answer is yes, you do have legacy software. And I think that's a good reason to be here. Otherwise, if you would have a new system, plenty of resources, developers, and money, probably there should be better time spent somewhere else. And do you plan to modernize your legacy software? I guess 81% say yes. And that's, I think, a very important answer. So let's move on. Normally, the software lifecycle of a product is looking like this. At the beginning, of course, after a lot of investments and new modules and growth, the product will become popular. We get a certain market cap, and then in time, will basically start to decline. And we are talking about a span of 20, 30 years, so almost 3 decades between a product is started, it goes through the market expansion and maturity phase till it gets to the decline phase. And the decline phase is almost always going to happen. The question is how fast and how steep is that decline? Most of the time, the decline is related to pressure from competition and technology debt. And these are also the major reasons you must spend on innovation. So if you're in a market in which the competition basically looks worse than you are, and you have no problems with technology debt, apart from the fact that, yeah, there is technology debt in pretty much all the larger products. My experience is that technology debt is more a matter of size and complexity than technology. So given a large enough project, regardless of the fact that it's based on new technology or old technology, you will have certain technology debt in there. This type of forces will kind of decide how steep is going to be that decline. My learnings from a technology debt perspective is that basically you can almost always kind of ignore that unless you are on a platform that's closed. So if you're on a platform basically where you have multiple suppliers, or your suppliers are not really squeezing you, and probably they are not going to squeeze you in the future as well. So we are talking about things like Java, PHP, Python, platforms, even .NET Core, the newer versions, platforms that are built mostly on open source or standard solutions. You don't really need to be afraid of the fact that your product is going to cease to exist at some point. So, and for this reason, basically, technology debt, although always it's going to be there, it's not really a major factor in deciding whether you need to rewrite a product or not. If, on the other hand, your product is based on a closed platform, something like an exotic 4GL language that they do not have any new customers left, basically they are declining and they need to squeeze their existing customers, then it's probably a matter of time till basically you're going to be in such a point that you either cannot support your product anymore because basically the platform on which is built is no longer supported, or your supplier is going to squeeze you as much as possible, and basically you will have pressure from a financial or a pricing perspective. So looking aside from the technology, the most important factor may be that will decide how steep is that decline is competition. If your competitors are very strong and innovating strongly, you cannot probably afford to not do so. So from this perspective, you need to counterbalance basically this downforce with continuing the new innovation and modules, and also doing the modernization part. Now, the big question is, where do you do your modernization? If we look at the type of systems that we have today, most of the legacy systems are basically systems of record. They are the source of truth. These are usually the old legacy monolithical solutions that most of the companies have these days. These are accurate, these are consistent, and these are basically the foundation and pretty much everything for most of your customers and users. On top of these systems, basically we have systems of engagement, and systems of engagement are lighter, smaller systems that allow or expose a part of the functionality of the system of record in such a way that the user is able to engage with that system in their own environment. We are talking about self-service portals that allow a specific functionality to be executed over the web by end users. We are talking about specialized mobile solutions or chatbots or anything like that. Something that would allow a specific persona or role or user to engage with the system of record through a more meaningful interface that in their own basically environment. And these days we are talking a lot about systems of intelligence. Basically, this is where rule systems, AI, machine learning is basically trying to support our users in making better decisions or making faster decisions. These systems are not really designed yet to take the decisions instead of our users, but they are designed to help the user. What happens is that the value being delivered by our products is not the same in all these systems. As you can imagine, competition on the systems of record is quite high. And because of this, the value and the margins that you can gain on just systems of record itself, it's small compared to what you can basically gain through systems of engagement and systems of intelligence. This is also one of the reasons why doing a rewrite is such a bad idea, because basically you're spending a lot of money, time, and effort in rebuilding a system of record, basically a system that has low margin and in which the competition is already high. Most of the times, if your competitors are really good, while you're rebuilding your system of record, they are going to start building add-ons and modules in the systems of engagement or systems of intelligence, think that they can monetize better and also provide higher margins. And I'm going to exemplify this with a situation with one of our customers. Basically, they are in the utilities segment. They had a customer information system. So basically the type of system in which power users will manage everything from billing, support requests, tickets, and so on. This company was founded in the mid-70s. So as you can imagine, this system basically went through at least one rewrite. But as you can also imagine, it's by now a monolithical system that happens to be based on a good platform. It's based on a Java platform. So it's not really threatened in existence in a short, medium, or long term. The fact that the typical users were power users for this system, it meant that the user interface is not that important. It is important to be productive, but coming up with a new version of the same system with the same functionalities would not really provide benefit to the end users. It would still be a web application. And in this case, the fact that it's a web doesn't really matter. You can have a native application. And for a power user, a user that's supposed to do this 8 hours a day, it doesn't really matter as long as the system is usable and is predictable. So the fact that they did not decide to invest in rebuilding the system of record, it was, I think, a very smart choice from their perspective. What they did instead was trying to invest in building a system of engagement. So a part of the functionality of the big monolith were related to workforce management. So as you can imagine, utilities, when something breaks with the power or when it needs to be a meter needs to be changed or verified, there is a field service worker that needs to go on the field and check that specific device. Now, they had all this functionality in the big monolith application, and the users or the field service workers were equipped with Panasonic toughbooks that they were hosting in the trucks, which at the beginning was a decent solution while there were not many competitors basically on the market. But as mobile solutions become prevalent, of course, users were a bit unhappy with that choice for mobile workforce management. So basically, they decided to rewrite or basically create two thin applications specifically for that functionality. One application was basically a web application that was designed for the dispatchers. And from this perspective, it's a very simple web application that only caters for the dispatchers. It only has the functionalities a dispatcher would need, but that functionality was designed in such a way that it was really, really appealing for the dispatcher in the way they interacted with the system. So user experience was very good for that. And also a hybrid mobile application that field service workers would be able to load on their tablets or mobile phones, that also this time supported occasionally disconnected application. So what happened with the previous application with the monolith is that, of course, if you don't have internet, then your application is not going to work. And also because it was a laptop that's usually stuck into their truck, they most of the time had to use pen and paper to note things down about what happened with the meter or anything like that. And then when they had internet, make sure that that data was entered into the system. With this new mobile solution, basically, we allowed them to go right to the meter, regardless of the fact that they did not have connectivity, because some of these meters were in the basements and so on, and basically use the tablet and phone functionality to capture pictures, to annotate everything they had. And with the proximal occasion that they had internet, all this data would be synchronized with the dispatchers and so on. So instead of basically investing in rebuilding functionality in a monolith and not adding value, they invested in building these thin slice applications that allow specific personas, the field service worker and the dispatcher for the service worker, to perform their action in a wetter environment in a more productive way. I will discuss also later how we tapped into the systems of intelligence for the same customer. But hopefully with this, you get a better picture of the layering and separations of the type of systems and the fact that where you invest your money matters a lot. Speaking of moving to the cloud and SaaS, there are multiple SaaS maturity levels. And at the basic level, basically, you have level 0, which means you don't have a standard software. Every customer has customizations that are done in the code. So it's kind of the worst situation possible. High maintenance, separate data, custom control of the releases, only vertical scalability available. So you need to add more memory, more CPU if you wanted to scale the solution. You had one environment per customer, but also no standard version. So basically each customer and each environment would have a different release. At level 1, you standardize the software. Now you have a standard software, but still it's not multi-tenant. It's one customer per environment still, but this time it's a standard software that you can go with standard configuration on it. Still high maintenance, still separate data. Customers still control the release dates and release control, for instance, in areas like fresh fruits or fresh products. This is very important. Still vertical scalability, still hosted on premise or customer, but basically these are the characteristics of level 1. At level 2, you start mixing customers together. So you have a multi-tenant environment, still high maintenance, but this time you can consolidate data. So you can basically start providing a better cost options by stacking together resources for different customers. Still only vertical scalability. This time, most of the time, it's a hosted environment. This is basically level 2. And level 3 is basically what we expect when we discuss about the cloud-native SaaS solution. So this is always hosted. It's one environment. It's a standard version. This time, it's horizontal scalability. So you can basically add resources as your customer grow, add additional machines as your number of customers grow. But in this time, your customers are no longer in control of the release date. And this is an important aspect you will see a little bit later. So basically, when you're doing a release, everybody gets the new version. No discussion about this. Well, you have options in dealing with some strategies in maybe partitioning this, but in essence, when you're doing an update, everybody gets the update. It's consolidated data, and also it's lower maintenance. Why these levels are important? Because basically, depending on the profile of the customer, not all levels are optimal. And we had a lot of discussions about, yeah, but if I'm level 3, can't I just serve level 1 customers? Of course you can. So if you're able to provide the high scalability, high multi-tenant solution, then of course that solution can most of the times be also installed to one customer and even on premise. So in theory, if you already have a level 3 solution, that's great. But the question is, what if you don't have a level 3 solution? And what if the step to get to a level 3 solution is very difficult? And from this perspective, in general, for high-ticket customers, customers that can afford to pay for the maintenance of a special dedicated environment, level 1, it's still kind of the most optimal SaaS maturity model. Why? Most of these customers, besides the fact that they can pay for the hosting, they also demand control of the release date. If you're targeting them with a level 3 solution, it's going to be very difficult to provide environments separately for them, or very difficult to provide separate releases for them. So basically, if you have customers that need to be able to control the release dates, then level 3 is going to be a huge problem for you. Also, with level 1, you're better able to deal with things like integrations. Although you have a standard solution, if your customers have different and specialized integration requirements, dealing with them at level 3, it's going to become a huge complication as opposed to dealing with them at level 1. So if your customers are larger customers, able to pay for the maintenance and hosting of your operation, having one environment per customer that you maintain is basically more optimal than having a more complex solution, horizontal scalable, in which you're hosting multiple customers. You're getting a huge optimization on cost, but optimization that is not as interesting for your customer as it is the control over their data and also the ability to integrate in the more complex scenarios. At level 2, basically, level 2, if you manage to get multiple customers on the same machine, you're able to reduce a little bit the cost. So in case your customers are in between tickets, smaller tickets, but still able to afford operations, hosting, and maintenance, level 2 can be a good option from this perspective. The problem with level 3 is that if your customers are low ticket, meaning that a customer would have a number of users, 1 to 10, and each of them would pay a small amount of money, between $1 to $10 maybe, it's going to be very difficult for them to afford a full hosted environment. So for low ticket customers, there is really no way to compete on long or mid-term without a proper scalable, configurable multi-tenant solution. So for that type of business that's moving towards low ticket customers, having such a level 3 is vital to actually be able to compete in such a segment. So what happens with your current legacy application? So basically, if you have level 0 and level 1, you basically can just lift and shift it and move it in your own hosting environment and make sure you're able to provide that service through a remote desktop connection, to a VPN, or any kind of connectivity options. If you need to cater for smaller ticket customers, then making sure you're able to optimize the hosting parts or able to build the proper level 3 complexity for them is very important. So if you're level 0 as your customer, as your software, make sure that you're able to standardize your application. If you're able to containerize that application, that will reduce your complexity in terms of maintenance or management. Not all technologies can be easily containerized, but if you're basically using an open source solution as a platform like Java or PHP or Perl or Python, then you have very good options to containerize that, and that would reduce the complexity a lot. Once you reach level 1, if you need to get more optimal in terms of cost and operations, you can optimize your solution. So basically, you can introduce multi-tenancy. You can introduce things like deployment automation to reduce operation costs and maintenance costs. Containerization, it's also very important in this part. And then the next point is scale. Once you have a multi-tenant solution, you make sure that you squeeze all the problems with vertical scalability and arrange towards a horizontal scalable solution. Now, in this part is already important that you have containers, because containers are very easy to orchestrate through Kubernetes. So basically, it will allow you more freedom and also will lower your operation costs when dealing with such, in general, complex architecture. Unfortunately, it's very difficult to jump steps for organization. So if you don't have an operations team, it's going to be very difficult for your software to turn it into level 3 and also learn the skills to manage a cloud native solution. Most of the times, it's easier to just go step by step through these levels. And also, as you get to these levels, to get the organizational and the processes required to maintain this type of level and processes. So it's not only about the technology stack and the architecture of your product, it's also about the maturity of your organization. If you have all the processes required to deal with the complexity of a level 3 SaaS solution as opposed to a level 1 SaaS solution. Luckily for this customer, they already had a Java solution, for they were able to just lift and shift and provide hosting and SaaS for their customers. The reason we could build those personas-based applications for the field service worker and the dispatcher was because they were able to provide an API. And you can have many types of APIs, but basically the easiest API you can use, it's based on standards. Web-based technology using HTTP, HTTPS, using XML, JSON, HTML, allows you to be almost client agnostic. It doesn't matter what type of client you're using to build the solution. If you're speaking JSON and REST APIs, you will most of the times be able to create this type of clients on top of your solution. And from this perspective, it doesn't really matter what type of technology you have on the server. Pretty much all servers these days, regardless of mainframes, iSeries, or just regular Windows or Linux boxes, have proper ways to expose this HTTP REST services as solution. So this is exactly what our customer did. They created an API that then we could use to build these thin applications on top of this. So an API is like a standard hook. You can use that to plug in pretty much all type of systems that you have. Smaller application, which are systems of engagement, systems of intelligence, mobile application, portals, web portals, any kind of lighter application you can basically build these days easily on top of an API. Now, speaking of AI, we have in general two types of AIs. Strong AI or broad AI. This is type of AI that tries to replicate the human reasoning. And weak AI or narrow AI. This is basically a specific piece of solution that focuses on achieving a specific task, behaves on that task like a human. Now, from this perspective, strong AI is still far, far away. It's not really a good choice yet if you're not Microsoft or Google to spend your money in trying to replicate human reasoning and so on. But on the other hand, weak AI is very well understood, and there's a lot of tools, both open source and commercial, that will allow you to build basically human augmentation or processes that allows you to augment your user decisions. Speaking in terms of the weak AI or narrow AI, you have in general three types of solutions. You have supervised learning solution, and these are excellent systems at extracting information or classifying information. They really can't do much beyond this. So if you have anything that needs to recognize patterns or needs to classify things in groups, and that thing can be an image, a text, or a sound, basically, then a supervised learning-based algorithm would be able to do that pretty much very well these days, and we have the tools to do that. You have things like regression and cluster analysis, and these are very good for estimations and predictions, or maybe anomaly detection. So you can build things that analyzes streams of data and tries to find outliers, or tries to do prediction, revenue prediction, defect prediction, any type of prediction. And these systems are very good and trying to help the users in providing data from this perspective. And then you have the good old rule engines. And these are very good for alerting and decision augmentation. And when we are talking about helping your users decide better, you don't need to look at the complicating things with supervised learning, ML, or regression or cluster analysis. A good old rule engine can basically do the same thing in a more predictable way. You can learn more about this from my colleagues. We have a presentation focused on AI. But the reason I'm presenting this is that there are specific areas you can use, specific technologies you can focus on that would allow you to get the benefits of these AIs. For instance, we help this customer with things like machine learning, specifically in trying to read meter data. You have these electricity meters, they have all kinds of weird ways to show data. And believe it or not, there are quite a large number of errors done by the field service workers when transcribing these data. So one way to augment them in this process is just using the same pictures that they took from the meters to automatically read the data from there automatically. And we had a couple of hackathons on this topic. In the first year, we were not really able to achieve good accuracy. We tried to build our own model for this. But the second year, we changed the model and we managed to get a very good accuracy. And this is actually one of the reasons why AI is a little bit difficult, Normally, you're building your logic in your application. So basically, the logic that decides certain things, it's in the programming. With AI and machine learning, the logic, it's in the data. The algorithms themselves are standard. But depending on the type of data and the accuracy of that data, you will get better or worse results. And to have that data, it requires a lot of samples. We are not talking about tens, we are not talking about hundreds, we are talking about 100,000s the time, most of the time. So in this specific case, of course, we had a lot of meters from our customer. We also had a lot of meters from the Google image part, but we did not have enough images with meters to train a model that's accurate enough. Now, the good part is that you can already buy some of these models. So actually, there are companies that are selling models with meters and so on. So you can buy the model, integrate that in your product, and have a very good accuracy in case you don't want to build that. The reason I'm saying this is because many times, if you have a legacy system, just like with the SaaS maturity model, you're not going to be able to jump from level 0 or 1 to level 3. You need to go through the stages. Same is with AI and ML. Unless you're using rule systems that you can easily program yourself, if you're using machine learning, you need to have the data. And most of the times, in order to have the data, you need to prepare yourself with a data strategy. And sometimes even to have your systems hosted by you to be able to get access to this data. So making sure that you start thinking about the data that you will need to be able to train those machine learning systems will be important for you to be able to deliver that systems of intelligence that would augment your user decisions. Already a bit over the time. So basically, make sure you're working on increasing the cloud maturity model. You're preparing your APIs because this is going to be your hooks into doing the innovation. You're collecting data for AI, ML, and choose the right SaaS maturity model. And of course, you can use an external partner once you have an AI to actually help you with this development. Okay, let's see. I know I rushed a little bit through this. Hopefully I did not lose you. Let's see some of the questions if you have. If you have any questions, just feel free to put them in the Q&A part. Meanwhile, I would really appreciate if you would answer the closing pool. Okay, no questions. Either I rushed it or I was very, very clear. I'm afraid it was the first one. Okay, first question. 50 years old front end, highly coupled and impossible to integrate with modern web technology. A rewrite seems inevitable. What's your suggestion? It depends what your user types are. If the users for these systems are power users, for them, it doesn't help that they have a new technology in there most of the time. So what you can do is clean up your system. And when I say clean up, well, if it's a web solution, it's maybe easy to add a little bit of lipstick on a pig, basically improve usability of the interface, adjusting the spacing, adjusting the fonting, making the user interface cleaner, more user-friendly and consistent. And this is in general, there is a sweet spot in there. So of course you need to find out what are the trade-offs, what's the kind of change that you can do without having to rewrite a big portion of the UI. And a good UI designer that also happens to be a good front-end developer or front-end developer will be able to kind of determine what's that sweet spot. If it's a native application or even a character-based application, I would look very closely to how the users are interacting with that. If these are power users, for them, it's not that important. Many times I find out that actually they don't care about the technology at all. Of course, they will say, yeah, we would like a newer application. But if you ask what is the current problem with the current system, they will most of the time specify things like missing functionalities and things like that. You have to be very careful with what developers believe, because if the R&D team will believe that the system is obsolete because there is obsolete technologies behind it, it can infect the whole organization. So the best thing to do is actually start questioning, discussing with your customers. My surprise was that many times customers would not really be interested in a web solution or anything like that. From their perspective, the system was usable, was fine. They wanted additional functionality. And this is exactly what you can do. If you do analytics and try to see what is the Pareto that applies to your system, 20% of functionalities that affect 80% of the users. If you try to do that by personas, you probably can find out use cases and scenarios for modernization. So something that you can use or leverage to build these smaller tier personas applications that either add functionality that you're missing and your competitors have, or basically remove part of the functionality from your legacy system as a way to modernize it slowly by delivering things that really matter to your users in a shape or form that makes sense to them. That's why I mentioned systems of engagement, things like portals that they can easily achieve their task without having to rewrite the whole system or install the whole system. Does that make sense? So I would be careful with trying to find out what the users want. And then if they want something else, try to find out how can I build that as a smaller persona-based application as an add-on on top of my legacy system. And in time, if you're doing this right, you will basically use the strangle pattern and have most of the core or critical applications into smaller, more maintainable applications that are easier to develop, less riskier to develop, and also you can monetize most of the time. Okay. Well, if there are no further questions, thank you so much for your time and attention. Have a great day.